Hi, I'm Akshay, and in this part we are going to study about RL, RC and RLC circuits when they are connected across an AC source. So RL effectively means resistance capacitance circuit. RL means inductive circuit, resistance and inductor is applied in the circuit, and RLC means that resistor is also there, inductor is also there, and capacitor is also there. So for this part we are going to study the circuits. Now the second question to ask here is how are these circuits connected? How are these components connected? Now R can be connected R and C can be connected in two ways. They can be either in series or parallel. Suppose they are in parallel, so they will act as individual units. Suppose they are in parallel, say RC we are talking about. This is a resistor and then there is a capacitor like this. So this is our EMF source. So this EMF source provides the EMF across the capacitor C and across R, and it keeps that value same for both of the components. So effectively the potential difference at any given time, which is across R, the potential difference across R at any given time is equal to potential difference across C, and they behave as individual parts of the circuit. So this will be a very simple circuit we've already learned to solve. So we'll only restrict our discussion to the combination in which all these components are applied in series, right? Okay, so next I'm just going to recap what of a few of the things that we need to understand, the basics which we need to have with us for solving this, which are AC. For AC current, we understand that the AC current is represented by I is equal to I naught sine omega t. Now that's a very basic type of AC current, and where I naught represents the maximum magnitude of the value of the current, and that value is maximum. So if this is the curve of I and t, and again this is also I and t, so what we can say is that the maximum value of current which is happening at which time, which is happening at after this much time has passed, say after this time, say t1, it achieves its maximum value, which is I naught, and then after again some time its value decreases, it again becomes 0. So in a way the value is changing from at t equal to 0 it is here, then it increases initially, goes to the maximum, then it starts to decrease again, goes to 0 again, and keeps on further decreasing, and to the negative side reach to a minimum value, and again goes to a 0 value. So this complete cycle from 0 to maximum, then 0, then minimum, negative minimum, then 0, we call it as one cycle. So this is one cycle. So in one cycle we should understand that how much time it takes to do this one cycle is called the time period. So one cycle, time taken in one cycle, time in one cycle is known as time period of the signal, and which is denoted by capital T. and if this was the current I sin naught omega t, so at t equal to 0 value of I will be 0. This is the curve which we get. So here we can completely see that if this will be the moment from t equal to 0 to this point, when it reaches, this is the moment when it reaches from 0 maximum, 0 minimum, 0. So this is the moment during which one cycle has taken place. This point will be the capital T for us, which is the time period. So this, in one time period, we see the value varies from 0 max, 0 minimum, then 0. And 2 pi by that time period is known as angular frequency, omega. Omega is angular frequency. And 1 by time is known as frequency, which is nu. This is frequency. Frequency, in other words, can be interpreted as it is inverse of time. So frequency just says that in 1 second how many this cycles has taken place. So frequency, in other words, we can represent as frequency just tells us frequency of an AC signal tells that in 1 second how many cycles have taken place. So if capital T is 1, we see that the number of cycles that has taken place in 1 second is 1. So the units of frequency is hertz. So we'll say for t equal to 1, frequency nu will be 1 hertz. If capital T is equal to 2 seconds, then we can say that okay, it takes 2 seconds to complete one cycle. 2 seconds for one cycle. So in 1 second we'll say 1 by 2 cycles. That is, v will be nu would be 0.5 hertz. That is, in 1 second half of the cycle is completed. So in t seconds, if t is the time period, how many cycles will be completed? In t seconds, one cycle is completed. In 1 second, 1 by t cycle would be completed, and this number is called frequency. So we get that frequency is nothing but 1 by t, right? So we can see that say we are given two curves, and this is the maximum value of, this is curve 1. If we want to name this is curve 1 and this is curve 2. So in curve 1 we can see that the maximum value that I0 reaches is I0, and say in curve 2 we call this value as I0 dash. So we can clearly see that the height of I0 is less than I0 dash. So we'll say that I0 dash is greater than I0, and these maximum value of currents are called amplitudes. So this is amplitude. So amplitude of 2 is greater than amplitude of one signal. Also we can say that in the same time interval, capital T, in the same time interval capital T, 0 to capital T, in curve 2, in the same time interval capital T, in curve 2 we can see that for curve 1, number of cycles is 1 in t seconds, capital T seconds. Similarly for curve 2, if we want to study curve 2, number of cycles is equal to dash in t seconds. Let's see how many cycles. So this is 0 max, 0 min, then 0. One cycle, this is one cycle, 0 max, 0 min and 0, 2 cycles, and this is 2.5. So the number of cycles in this case for us is 2.5 cycles in capital T seconds, right? So number of cycles are 2.5 in capital T seconds. So frequency of our curve 2 will be 1 divided by capital T, no, 2.5 divided by capital T. Because in T second cycles are 2.5, in 1 second cycles will be 2.5 by T, this much hertz. And for curve 1 we can say that frequency for first curve would be, we know it is 1 by T. So if we look at the graph of these two, if we are to consider about frequencies, what we can see is that the spacing between the consecutive touch of the curve at x-axis, if the length of the part between consecutive touches on x-axis or the time axis is greater, we'll say that it has less frequency, right? nu1 is less than nu2. And if we see in our curve, it is clear here that it touches the time axis in a length of this much, while the two consecutive touches for curve 2 happens in very less time, it is almost this much. So frequency, so the length in 1 is more, the length in 2 is less between consecutive touches. So we can say the length of consecutive touches, if the length of consecutive touches is more, if the length of consecutive touches is more, if the length of consecutive touch of curve on time axis is more, we'll say it has less frequency. Okay, so we'll say that it is more in one curve, in curve A, and less in curve B. We can say that frequency of curve A is less than frequency of curve B. So this is quite clear to us, right? So if all this is clear, if all this is very much clear, then we can move on to our next thing, that is RC circuit, RL circuit and RLC circuit, and which will be continued in the part 2 of this lecture. Okay.